Hello, my name is Nick Huntington-Klein. I'm an economics professor at Seattle University. Something that I think about a lot is research design and how it works. And when I'm working with students on doing their research, which is something that I often do, something that I find is one of the more difficult aspects of research and planning research and coming up with it is to come up with a good research question. It's one of the more difficult parts of doing research, at least for people who are new to it, right? It requires you to think in a different way about how to learn things. When we are learning things generally, right, there's often some sort of right answer out there, so people can just tell us sort of how things work. And when we are trying to ask ourselves questions, we end up asking those questions in almost a confirmatory way. If we are learning about gravity, for example, is an example that I'll come back to. We learn about the model of gravity, and then we think, okay, well, how can I learn more about this? Well, I'll read more about this, right? And the idea that you are going to learn something new from the world, from what the world can present to you, requires you to think in a different way about how it is that you gather information, as opposed to learning from somebody else that already knows it. You have to think in a way that allows you to learn from an uncaring world that does not care whether or not you learn something, and is going to require a little bit of finessing to figure out how you can get something from the world and use that to generate an actual interesting insight. And that's the whole point of research. So students do have lots of curiosities. They're interested in things, but turning that into a research question that works can be very difficult. That's what this talk is all about. So I'm going to take a little bit of a detour first, which is how about reproducibility? Some reproducibility is also something that I'm very interested in. The idea that when research has been done, somebody else can then do the same research and come to a similar conclusion. And there are a lot of different aspects that make things more reproducible, and it's an important part of how science works generally. But the core underlying principle is that you have done some analysis, some research, and you have used that to generate a result. And from that result, you can come to a conclusion. And we want it to be the case that when somebody else studies that same question and comes to a conclusion about whatever it is that you're interested in, that it should ideally match the conclusion that you came to in your work, right? That's what we've replicated the work. We've made it so that we can replicate what's going on there. But there's different ways in which this can fall apart, right? One way is that you could just have a fluke result or something like that. But it can also be the case that you just have a poorly defined research question. Right. If you have a question that if you have a theory that you're trying to address about the world, you have a curiosity that you're trying to satisfy, but the research that you're doing doesn't actually answer that question, then the conclusion that you come to is not accurate. Even if you've done the research in the proper way, the conclusion that you can draw from it is not accurate. Which means that when somebody else goes to study that same question, maybe taking a different approach to it, but that should still be answering the same question, they're actually not answering the same question as you were. And so it's no surprise that they might not come to the same conclusion. So starting out to try to get any sort of reproducible work at all means that you have to start with a well-defined research question that actually answers the curiosity or the thing that you are interested in learning about. So we have to have a good research question, and this is very difficult to come up with for newcomers. Newcomers have interests and curiosities about the world. It's not that difficult to get to somebody to talk about the things that they are interested in or curious about, but it's very difficult to turn these things, these interests and curiosities, into scientific research questions that can actually be answered. Having a well-defined research question for a student is going to make it easier to create research that actually answers that question. Right. And then when you've done that, it will actually address the theory that you might have about the world and therefore actually contribute to the scientific literature on that topic. Or at least that they generate something that you can trust at the end. I can't tell you how many times I've led student research projects where, the research question was not quite right. And then the results don't really make sense. Why not? Because they're not actually answering the question that you think that they're answering. And so at the end, you just have to start to say, well, you've done your work. Let's see what you have, but don't put that much faith in your actual results. That's a disappointing thing to have to hear, right? When, for whatever reason, the results that are coming out of your research are simply not trustworthy. And one of the coolest things about doing research as a student is that you are having the ability to generate actual knowledge for the world for the first time. And if you don't have a proper research question in place, then the results that you generate are either fooling you or not fooling you, and you recognize that they don't actually mean anything, which can take a lot of the excitement out of it, and it's going to make a student less interested in pursuing research in the future. So we have to come up with a decent research question for this to work out. So let's talk about how a good actual question can help get us to actual useful results and reproducible work that actually addresses the question that we're talking about, and also how we might fail to do so. So let's take a general interest the student might have, a curiosity the student might have about the world. Let's say they're interested in whether playing violent video games spurs aggression. This isn't the trendiest concern to have. I mean, I haven't heard anybody do studies on this in a while, but it's a well-defined one we can think about. So that's the curiosity that we have, but it's not a research question, right? Does playing violent video games spur aggression? That's a theory. I have this theory that I understand where aggression comes from. I think it might come, be spurred by interacting with violent things in some way. But what's the actual question that I can ask? And a research question has to be about the real world, something that you can actually see, right? So, for example, you might ask yourself, does violence rise after the release of a popular violent video game like Grand Theft Auto 5, right? That's one research question that you could ask. You could actually study that specific question, and ideally the answer to that question will help inform what you think about whether playing violent video games spurs aggression. But there's other research questions that you could ask as well. Does somebody's forehead temperature rise after they play violent video games for 20 minutes? Is that enough? Do we need to compare that to somebody playing video games that are not violent for 20 minutes, right? Maybe that's an extension of the research question there. There are lots of different possibilities. Let's say we land on this particular form of a research question that might help answer our curiosity. Do people who play shooting games, which are violent, demonstrate more aggression than people who don't? Right? That's one research question that we could ask. Now, we obviously can see the problems with this particular research question. We might be likely to get a positive result, even if it's only because of the confounders in this question. Who chooses to play violent video games? It might be people who are more prone to violence in the first place. I don't know if that's actually true, but that is one possible explanation of why we might see a positive result there. So because of that, the research question that we've landed on here doesn't actually address the topic of interest, right? Whatever conclusion I come to about the answer to this research question, it doesn't actually inform the theory, so it's not a particularly good one. Right? The student goes out, they do this analysis, they come back, they give an answer, and you say, yeah, okay, I see that you got a positive result. That doesn't actually tell you whether violent video games spur aggression, because there's these gaps in the research question, between the research question that you came up with and someone that would actually help you answer your question. So how can we then help this student figure out how to land on a good research question? There's a couple steps that we can use to turn a curiosity that somebody has, and that curiosity can often come from a hunch about how people think the world might work. I think that maybe violent video games cause aggression. It could just come from some topic that you're interested in, which students have no trouble coming up with that as well. Let's say we're curious about a topic. Let's say we are curious about violent video games and their relationship to aggression. And of course, the first step is to learn a lot about that topic. Students, it's hard to come up with a decent research question if you don't have a lot of background knowledge to work with. But you can ask yourself, right, after we learn a bunch, we'll read a bunch about this topic, what people have found in the past, and we can ask ourselves, what is the theory about how things work? And the theory that we have here is a theory is just an explanation of the world that has some sort of why or because going on. It's a very general concept of a theory here. We are explaining why the data is the way that it is. What's the underlying process that explains what we're seeing, right? And it could be as simple as this. We think that violent video games cause people to be aggressive. That's our theory here, right? That's what we think is going on under the hood. Whatever it is that we see, we think that that's sort of going on there. So we can ask ourselves then, right? So here's the process of taking that curiosity or that theory that I have about the world and turning it into a research question. The first thing that we should ask ourselves is if we are right. Let's assume that we're right for a second and that violent video games do in fact cause aggression. We can ask ourselves, what should we observe in the real world, right? What is the observation we would be likely to have if in fact we are correct, right? So one observation that we might be likely to have is that someone who's played a violent video game is going to be more aggressive than someone who has not. Right? That's a possible observation we might have if in fact we're right. Then we can ask ourselves, if we do observe that thing in the real world, let's say that we get a bunch of people and we observe that people who play violent video games do exhibit more aggression, however measured or defined, than people who don't, right? We do observe that, okay? So can we explain that observation in ways other than the hunch or theory that we had in the start? What are the alternate explanations for the data that we see? Let's assume that we do see what we expected to see. How can we explain that outcome in ways other than the thing that we wanted to see in the first place, right? So you might see that more aggressive people might choose violent video games, right? That's one possibility. We could say, I observed that people who played the games are more violent. That's just because they chose them because they were violent in the first place, right? And then we can ask ourselves, okay, well, I can come up with this alternate explanation. How can I change the thing that I am looking for such that that can't be an alternate explanation anymore, right? And the reason why this alternate explanation works is because people are able to choose the games that they play. So somebody who's more violent already might, more aggressive already might choose the violent video game. But if I can make it so that you're not choosing a game at all, then that can no longer be an explanation. This might push me towards a randomization approach, right? If I randomly assign you to play a violent video game or not, then it can no longer be the case that you are playing the violent video game because you were more aggressive to start with. So I've started with my hunch. This led me to an observation I might expect. I can then think about what happens if I see that observation. Can I explain it in some other way? And then thinking about what other explanations are there might give me an idea about alternate things I could look for which that alternate explanation no longer applies, right? In this case, randomization solves our problem, or at least gets rid of that alternate explanation and gives us a thing that we can actually look for. I can now I got to go randomize something. So that's our process that we can take to get to a feasible potential candidate for a good research question. So we now have one in mind. I'm going to randomize my people into either playing violent video games or not, and then I can check whether aggression seems to be higher among people who do get randomly assigned to play violent video games versus not. I'm, of course, going to have to get a bit more specific. What does it mean to play the game? How long do you have to play it for? What kind of game does it have to be? Do I need to pick different games, right? There's lots of choices here from this point on, but we have the general structure of what it is that we are looking for to sort of give ourselves a baseline. We have an idea. So we have a research question, and we can then evaluate whether this actually is a good research question. There's sort of a checklist approach that we can take. Students are more likely to get a good thing if they can go through a checklist and see if it actually makes sense. We can go through this checklist for any given potential research question that we have and ask if it fills all the things that we need it to do to become a good research question that we can actually base our project off of. And here are the 5 things that we're going to look for to try to see if we have a decent research question. The first is we're going to consider the feasibility of carrying out research with that research question. We're also going to consider the scale of the project that it implies. We're going to consider potential results, which we've already done a little bit of, but we're going to do some more as well. We're going to consider the design of the research that this research question implies that we need to do. And then finally, we're going to try to keep our research question simple, nice and simple. So let's go through this process one at a time. So the first thing, we're going to consider the feasibility of our research question. So we can ask ourselves, is the research question possible to answer with realistically attainable data? Right? Can you actually answer this? Right? So in the case of violent video games, we can imagine setting up an experiment where you randomly assign people to either play a violent video game or not. There are, however, other things where if that's the solution that you came to, you would not be able to randomize, right? If I want to know the impact of, let's say, a minimum wage, no one's going to let me randomly assign a minimum wage. And so if I come up with a research question that requires me to randomly assign minimum wages in order to figure out what the effect of that minimum wage is, well, there's not really feasible data out there that will allow me to answer this research question. If I want to get at that curiosity, I'm going to need to find some other research question that addresses it in a different way. So we can ask ourselves, is the research question possible to answer with realistically attainable data? That data might not exist, right? Maybe it's not possible to run that experiment. Maybe it relies on data that just can't really realistically be attained. Maybe I'm a nutrition researcher and I think, I want to know what's the effect of your diet last year. Hey, I'll have you write down a diary of what you ate this day last year, right? That's just not realistically attainable data because you know that whatever you got would be garbage. So sometimes data might theoretically exist, but not be feasible to get or procure. I can't randomly assign you to minimum wage or not. I can't feasibly ask you to write down what you ate for lunch last year. But I need to consider this feasibility generally, right? Can I actually get this data? Can it possibly exist? So with our question, do violent video games cause aggression? And if our research question is, do people randomly assigned to spend their childhoods playing video games exhibit more aggression than people randomly assigned to never play them, right? Maybe I think randomly assigning you to play it for 20 minutes doesn't do it. You got to play it for your whole childhood. Well, no one's going to allow me to randomly assign children to either play the games or not. And even if they did, it would take me 20 years to see any sort of results of my work, right? So that's not really feasible to answer that particular research question. Let's say I'm curious, do self-employed people misreport their income? Right? Maybe this is my curiosity. Maybe my research question is, do I see discontinuities at convenient income amounts in the full set of U.S. tax data? So, what I do here, right? Maybe there's some sort of tax credit that cuts off at a certain income, and I can say, hey, does it look like self-employed people are really likely to just get a slightly less, $1 less than is the maximum you can earn and still get this tax credit? Well, that would allow me to answer my question. And if I do have access to the US tax data, and some researchers do, then I can answer that, right? That is a feasible research question to answer. The data does exist out there, but the question is just, do I have access to that data? I don't. So that is not a feasible research question for me to answer, even if it makes sense theoretically to be able to answer that question. It's not really feasible, certainly for a student, for most researchers as well. So similar to feasibility, we can ask ourselves to consider the scale of the project. This is especially important for students, right? Students are not working on, grand research timelines with huge budgets. Most of us aren't either, but students certainly are not. They usually have a project that they need to do within the span of one term, right? With basically zero budget across a bunch of other classes that they're also taking at the same time. So we have to ask ourselves, is the research question possible to answer within the allotted time and with the resources available, right? Student projects are very small, and they are done by students who have never done this before. And so whatever it is that they're doing is probably going to take them longer to do than it would take a researcher. And they don't have access to a lot of things that a researcher might normally have access to. Including things like assistance, right? So can you actually address your research question within the allotted time and with the resources available? Like I said, there's a link here between this and the feasibility. In the case of this U.S. tax data, this might be something that a professional researcher with ties to the U.S. Tax authority might be able to do, but certainly a student would not be able to get their hands on that data to answer that particular research question. So let's think about some other potential candidate research questions that we can evaluate whether scale makes sense in this case, right? We're curiosity, how are auditory messages delivered to the brain, right? Well, a research question might be, what neural pathways light up in what order in response to provided auditory stimuli in patients under active brain scanning? So what's the data that would be required in order to do this, right? We need some access to some sort of, neural scanning lab where we have the ability to provide auditory stimuli to patients under active brain scanning. I need to actively scan your brain while I'm doing this, or put you in an MRI so that I can watch different parts of your brain light up. If you happen to be in that lab, then that might be something that you could potentially do, but that would be quite a large amount of resources to dedicate to a student research project, right? Even if the data is feasible and it exists, you're probably not going to be able to do this in the context of a single term research project, at least not in most cases. Maybe you happen to have special access to this data, or you happen to be a part of a lab. Maybe a grad student may be able to do this, but not so much a undergrad, right? The scale of the project is important, which is, something to keep in mind, right? A lot of students don't go into these projects realizing the limitations that are going to be on the data that they have access to. Further, I think there is a tendency among students when they have limited access to data to just say, well, the data that I have, it's the best that I'm going to have access to, so I'm just going to go ahead with that, and that'll answer my question anyway, which in the context of a single term might actually be the right way to go about it, right? You have to work with what you have, but thinking about the process of what is the data that you'd like to have, and is that feasible, and will require you to, at the very least, acknowledge the limitations of the data that you do have access to. Something that I do notice among students is, upon realizing the limitations of the data, they will then ignore the limitations of the data. Since it's not their fault that they can't answer the research question, the the fact that they need to remember that they are not actually answering the research question, or that they are not actually answering the research question that they should be answering, sort of goes out the window. And so if you are in a case where you're teaching students who have very limited access to data that only allows them to answer certain questions, it is important to stick with them and help them remember that there are these limitations to what they're able to do with the data that's available to them, and that while it may be fine to do that in the context of a term project where you simply can't do much more, that doesn't mean that you can drop those limitations, that they need to carry that with them. And it should color the interpretation of their results, right? Like I said, you end up with wishful thinking of trying to answer the question that you can no longer answer because of the limitations here, right? This step in the checklist makes you realize that those limitations are there, and hopefully remember that you can't just leave them at the door once you've acknowledged, or once it's no longer your fault that you can't do any more than that. Another research question that we might see here, or a curiosity we might have, is what makes some countries rich and others poor? So maybe the research question that comes out of this, you can ask, well, when market economies are introduced by historical happenstance, does economic growth quickly follow, right? This might be a feasible thing to address, right? Maybe you have economic growth data on countries over long periods of time. This data might have already been collected by economic historians in the past. It might be easily accessible to students, right? In this case, maybe you do have the ability to get this data on hand, unless it hasn't been already collected for you, in which case it's much too grand of a project to collect the data in the first place for a single student. All right, so in many cases, the scale can, or the feasibility or the scale of your project can come down to how much work has already been done before you, right? There's certainly plenty of projects that are feasible because there are people out there like IPUMs who have collected a bunch of census data and put it in one place for students to use. That would not be feasible if students had to go and learn the census files and data for themselves. All right, next up, after we figured out whether we have a question that is at least at the proper scale and feasibility, we have to consider the potential results. We already talked about this a little bit when we were trying to generate the question in the first place, right? We considered the potential result that might come from our theory being correct, and then we asked ourselves whether there were alternate explanations. And when we've done that to generate our research question, we then need to come back to it to evaluate our research question further, because there's usually plenty of alternate explanations that might be able to lead to a particular outcome happening in the data. And so you might come up with a couple in the process of leading you to the research question in the first place, but you need to evaluate it over and over again as well. So maybe you run an experiment, and in the group A in the experiment, the average outcome is 3 units higher or 3 units lower than it was in group B, right? That's a feasible conclusion that you might run to if your research question requires you to randomly take two groups and get some measurement out of those two groups after assigning some sort of treatment. You have to ask yourself, what's the conclusion that you're actually able to draw from that result happening, right? What you see here in this case, group A is 3 units higher than it is in group B. That's what our outcome is. It's what our average outcome is, right? Ask yourself, does that actually address the curiosity that you have? Or is there some other explanation that you could come to, right? Let's say that it's a pill. We're some sort of drug company. Maybe we're no longer a student. We're able to randomly assign a pill. And I think that this pill is going to help make group A 3 units higher than group B. But then it turns out that I run the study and actually group A is 3 units lower than group B, right? Unexpected result, right? And that's an important part of this, is to not just consider what the results you think you are going to get, which was what we did when we were generating the question in the first place, but also to consider what might happen if we get results that we don't expect. Because then you can ask yourself, well, there's a natural tendency to want to explain that result away, right? We have this idea, I think that maybe violent video games cause aggression. Oh, but I did my analysis. It turns out that actually I found that the aggression levels among people who play violent video games are lower than they are among people who don't play violent video games. Well, okay, but I really like my theory, so I'm gonna be able to generate some justification. I'm smart. I'm a smart guy. I can figure out why I'm still right, even though I've seen data that shows me that I'm wrong, right? Which is actually a really good exercise to get into, because what that forces the student to do is come up with the alternate explanation immediately, right? It's easier to come up with an alternate explanation for your results when the results aren't what you want them to be, which is a bad tendency if we then run that all the way to publishing things that we do like, right? But it's a great tendency for finding out those alternate explanations that we then need to realize, hey, if you can explain away a bad result, then a good result probably doesn't mean much either, right? That tells us that our question is not very good. If you can wriggle your way out of a bad result, then you can also wriggle your way out of a good result. And you should, in fact, wriggle your way out of a good result by coming up with alternate explanations for the results that you might get. Do violent video games make you more violent? Right? Let's say that my research question that I come up with this as a result is: do I see higher aggressiveness scores among people who play violent video games compared to people who don't? So again, we're just sort of looking in the observable data. We're measuring aggressiveness in some way, and we're seeing that it's higher among people, or higher or lower in people who play versus don't. One possible result is that people who do play violent video games, on average, show more aggression on whatever our aggression scale is. And I think, great, that's one potential result that I might get. I thought that violent video games made you more violent as a result, or more aggressive. So, yeah, okay, that totally satisfies what I was looking for. That proves me right, right? But imagine for a second that, in fact, I found the opposite. For whatever reason, right, I look at the data. It turns out that people who play violent video games are less aggressive on the aggression scale that I have than people who don't play them. Oh, okay, well, that's, maybe people who are violent, they choose not to play the games because they don't want to, accidentally make themselves angry and then they're going to go hurt somebody, right? They're aware of it, right? So that's why they choose not to play the games, right? In doing, by wanting to still be right, I've come up with a way in which the data no longer actually answers the question, right? I've weaseled my way out of having to conclude that I was wrong, even though I have evidence that goes against what I thought I was going to see. But by being able to do that, by saying, oh, well, maybe it's just the people who are more violent, they choose not to play the games. Well, now I can flip that around and say, well, maybe if they were more aggressive, that's because they choose to play the games, right? So the same explanation, the same alternate explanation of the bad result will often also apply to the good result, what I wanted to see in the first place. This is a good psychological trick of getting around the tendency to want to confirm our own theories, like considering those potential results. Here's some more examples, right? Let's say I'm interested in figuring out whether people think more fondly of Taco Bell or Chipotle. And if this feels like an odd curiosity, I can tell you that in doing research studies, I get a lot of student research questions that look kind of like this, right? Granted, I teach in a business school, but still. So maybe the research question I end up with is I'm going to look on Twitter, or I'm going to look on Reddit. I'm going to look and count how many posts with positive sentiment there are about Taco Bell compared to Chipotle. I'm going to scrape a bunch of web social media posts. I'm going to rank them on sentiment using some text analysis method, and I'll count up how many positive posts there are about Taco Bell and how many positive posts there are about Chipotle. Result that I'm going to get: there are 10 million positive posts about Taco Bell in the past year, but only 3 million about Chipotle. And seeing this written down, I will now realize, wait a minute, maybe people just post more about Taco Bell in general, whether it's positive or not, right? At the very least, this is going to make me want to go back. And I'm not even disconfirming my expectations at this point. Maybe I did think that Taco Bell was going to be more popular. But at this point, I can look at this and go, oh, wait a minute. Taco Bell is just much more popular than Chipotle. It's just a much bigger brand. People are going to post about it more, whether it's positive or not. So I'm going to need to go back and revise my question to think, what about the share of posts with positive sentiment as opposed to the total number? And I can tell you, again, this is a very common mistake that students make, especially when they're working with observable data. They tend to default to counts as opposed to rates. And this is a good way to catch them. I mean, this particular issue, that's one way where they can get caught out on it, but it can catch all sorts of other issues like this as well. Here's another one. Do people exhibit the halo effect when they're thinking about celebrities, right? This is a psychological halo effect. You think one positive thing about somebody, that means that you assume that other positive attributes also apply to that person. Maybe the research question that I have is: how have review scores of Beyonce's music changed over time compared to how review scores of Kanye West's music change over time? And maybe I find this result: review scores for Beyonce have gone up, review scores of Kanye West have gone down as their vision in the public eye has changed over time, right? That's one possible result that I might have. I might think, well, okay, well, how else can I explain this? Well, maybe the music has actually gotten better for one of them, and the music has actually gotten worse for one of them, and it's not just their public perception, right? So I can obviously immediately think of an alternate explanation as to why I might see this result, which might make me reconsider the research question that I came up with, right? I might reconsider what I'm going to do. One more, right? Is red a more attention-grabbing color than blue? Another psychological question, maybe with this one about visual perception. And maybe a research question is this: in text that's randomly colored red or blue, do people look at an people who are in an eye movement tracker, look first at red words, then at randomly assigned blue words? And maybe I find the result that 60% of people look at the blue word first, and 40% of people look at a red word first, right? And I could think, well, is there some other way that I can explain this happening other than red just being more attention grabbing? By whatever definition attention grabbing is. It almost seems circular at this point because it seems very clear that this does suggest that blue is in fact more attention grabbing than red. This is the unexpected result, but it's hard for me to explain away other than sort of coming back to the original result that I had. This might suggest that maybe I do have a solid. This one then sort of passes the test. And I had a lot of examples for this one. I think because it's such an important, that's right. I had a lot of examples for considering the potential results because I think it's such an important part of evaluating a research question for students because it forces them to think through the entire process of their work, B, consider the results that they're going to have at the end, which is again something that students tend to not anticipate. When it's very common for students to get to the end of a research project, have the data, and then realize they don't know what they're actually going to calculate, right? What are you going to take the average of to compare against one thing against the other, right? It's usually an unexpected thing for students, and forcing them to think through the results first makes them think about it ahead of time so they know what they're headed for, which can also help them avoid some issues in the data collection process so they actually collect the things they need to collect if they're collecting data. And then also makes you think about whether your research question is good, because if you can come up with a result and then explain away that result in a way that does not go along with it does not actually answer your question, it tells you that you have some more work to do on your actual question. Next up, we want to consider the design. Do we actually have a design for our research, a research design that lets our research question be answered? We're sort of going another level down. We started by asking, does the research question actually answer our curiosity? But then we can ask, does the research design that we have answer our research question, right? Can I actually answer the research question itself? Going back here, right? My curiosity is red more attention grabbing color than blue. My research question is, in this eye tracker, what's the share of people who look at the red word versus the blue word first and a randomly assigned one? I do think this research question probably does address, if not fully answer, the curiosity that I have. But does the design that I have of putting people in an eye movement tracker and collecting which one they looked at first, does that actually answer the research question? I could probably say that it does, but not all designs do, right? Once you have a good question, and we know that answering the question can inform the curiosity that we have, can we actually implement a research design that answers it? So let's go back to our standard example here. Do violent video games cause aggression? Maybe this is the version of the research question that I go with. When I'm randomly assigning lab participants to a 1-hour gaming session that is either a violent or non-violent game, is the average before to after change in aggressiveness scale higher for those assigned to the violent condition? Well, there's some things left out, right? This forces me to think about the details of my research question in actually application. I've sort of assumed that I have a way of measuring aggression here. Do I actually have that? Does the aggressiveness scale actually work, right? Do I have construct validity for this, for the scale that I'm using? Is 1 hour enough to actually answer the question, right? Can I actually get people to play the game for an hour? Are they going to get bored and stop playing? And I'm going to get a lot of people not going along with the treatment that I assign them. How long can I expect to see the effects for? I didn't put in my research question when I'm going to measure the aggressiveness, right? Am I going to wait a certain amount of time? This will force me to, first of all, see holes that I've not anticipated in my question, right? Things that were not specific enough, but also design-based questions, right? Can I actually measure aggression in a believable way? When I get that back, the average aggression score is 1 unit higher in one condition or another. Do I actually think that this is telling me whether the average aggression is higher in one condition, right? Knowing whether the average aggression is higher in one condition versus another does answer my curiosity, but does the scale that I have selected allow me to answer the question? If I picked a aggressiveness scale that, for example, has enough variation that I can see a difference? Have I picked an aggressiveness scale that I think actually tells me about aggressiveness? Do I have a good measurement? Here's another example. Does air pollution harm cognitive performance? Is my curiosity, right? Does having bad air make you think worse? Here's my research question. In cities where random variation in wind direction determines air pollution level, so you have some randomness in the level of pollution that you're exposed to, because in some days the wind blows west and it blows all the factory smoke into the city, and in other days it blows east and it blows all the factory smoke out of the city. So the air pollution is better on those days, right? In those cities, our academic test scores correlated with wind direction. I think answering this question would actually tell me about the curiosity, right? It would deal with the fact that some people just live in better or worse pollution areas. It only gives me, short-term effects, right? Only 1 day effects at a time, but maybe that's a part that I'm willing to focus on. But for this to work, for this research question to actually be answerable, I need to believe that wind variation is in fact random. Is it? Right? I'm making that assumption here. If that is true, then this research question does answer the curiosity, but I need to assume that. Do I actually believe that that is true, that wind variation is random? Maybe it's not random, right? Maybe it's the case that, on days where the variation maybe it's predictable, right? Maybe people choose to run the factories or not based on what the wind is going to be, right? There's certain different ways in which I might expect that wind variation is not truly random relative to the cognitive performance, and so therefore I can't actually use this design to answer the research question. Lastly, we want to keep our research questions as simple as possible, right? Students have a lot of curiosity into a given project. They don't like narrowing things down to a single answerable research question, right? People like I said, when people or students are coming into research for the first time, it's very different from answering questions in other domains, right? When you are learning in school, it's great to be able to be exposed to lots of information and sort of a breadth of explanation. But that doesn't really work in research, where the things that you're actually capable of doing are often very narrow and specific, especially in the scale of a student research project. Even outside the scale of a research project, if we are professors writing papers, we only focus on one question at a time. There's only so much that you can do in the space of a single research project. So definitely true for us, but even more true for students. It makes sense to narrow things down as much as possible. There's lots of curiosities I might have, right? How did the invention of perspective affect Renaissance painting? I'm curious about that, right? How do we make decisions? What determines social mobility? How does racism affect the lives of indigenous people in the United States? These are good curiosities to have, and we'd like to know the answers to these questions, but it's very unlikely that any research question that we come up with is going to actually answer these questions because they're so broad, right? And so coming up with a research question that can actually address these curiosities is going to be likely to end us up with something that we can't actually answer. I mean, any research question for these is likely to be too broad in a way that we can do it, right? Honing down a good research question is neither going to be automatic nor easy. Having a research question that actually answers this is likely to be too broad, right? Because these curiosities is going to be what determines social mobility? Probably a lot of things, right? This doesn't mean it's a bad curiosity to have. It could even lead to a decent research question as long as you're willing to narrow that research question down to just a tiny slice of it, right? What determines social mobility? Well, maybe every research question could be, does this particular thing affect social mobility in some way, right? That's an answerable research question, but you need to be able to take the student from, hey, if this is the thing you're curious about, I need you to narrow down to just answering a tiny part of your curiosity. That's the real honing part of this step on the checklist, is making sure that the student is able to take that giant curiosity that they have and be willing to only answer part of it, right? In the case of social mobility, or in social science generally, something that students love to do is say, okay, I'm curious about economic growth, or I'm curious about decision making, or I'm curious about social mobility. So I'm going to take all the things that I might be interested in, I'm just going to chuck them in a regression, and I'm going to say, okay, I've got 12 different coefficients, and now I've figured out social mobility, right? And that doesn't work, right? But it is a natural tendency because they recognize that this is a complex thing. They want to explain the complex thing. And so the research question that they end up with is, how are these 15 different variables correlated with social mobility? And that's not a good research question, right? That's the part that's important here. It's not that we need to drop the curiosity. It's that the research question that we come up with to answer this curiosity, we need to recognize we're only going to get at a tiny slice of it in any one particular research question. And so it's being willing to pick a specific research question that answers part of the curiosity rather than picking a research question that does a bad job addressing the entire curiosity all at once. We got to keep it simple, right? Even a professor addressing this would not dare to try to understand the entire set of determinants of social mobility all in one project because they know they do a bad job. right? They need to be able to slice down a bit thinner to be able to answer a specific research question well that will address a part of the curiosity as opposed to doing the entire thing all at once. So there's two ways to actually solve this problem. One is to get a narrower curiosity, but that's a terrible thing to have to tell students. Rather, it's be willing to pick a research question that is simple enough that you can actually answer it, even if it only addresses a part of the curiosity that you have. So in conclusion, bringing all this together, right? Coming up with a good research question is neither automatic nor easy, especially if it's not something that you've never done before, right? I've come up with a lot of examples of research questions that work or don't work in this presentation, right? And showing those examples to students can work really well, right? You want to show students good and also bad examples of research questions that don't work or do work, right? To help guide them in good directions, to see what a good research question looks like, but also what are some research questions that don't work and why, because it's not obvious off the bat why those questions wouldn't work for a lot of students who haven't done research before. Why do you mean it doesn't work to just, I mean, if I'm interested in violent video games, why can't I just compare people who play them versus don't? Like that's the most obvious thing to do. You're telling me that doesn't work? Well, why doesn't that work, right? Yeah, why is that an example of a bad research question, even when it seems like the most obvious thing to compare? In my case, in economics, right, an obvious thing to do if I'm interested in the effect of something is to say, hey, I want to know the effect of a minimum wage. Well, hey, minimum wage went in on this date. It changed on this date in, let's say, Seattle, where I live. So I'll just compare, let's say, the employment levels before and after. Most obvious thing in the world. Well, why doesn't that work, right? I can give that as an example of a bad research question. How did employment change from before the minimum wage was introduced to after? And I can explain why it doesn't work, right? Because there's all these confounders that could be happening at the same time. Maybe the employment level is not going to get affected right away, so I wouldn't actually see it. Hey, if I see that employment levels, if I don't like the minimum wage, I think the employment level is going to go down, but I see that it went up. Well, yeah, that's just because maybe it hasn't had time to have an effect yet. Well, if I see it go down, maybe it hasn't had time to have an effect yet either, and have something else going on at the same time, right? Coming up with alternate explanations helps you figure out why those research questions don't actually answer the question of interest, which is, does the minimum wage reduce employment or not? So this checklist approach can help navigate those confusing waters to help you go from curiosity to having a candidate research question, and then using the checklist to figure out whether that research question actually works or not, or if it requires further revision to come up with a version of a research question that actually does address the curiosity that you're interested in and is on the appropriate scale to be able to accomplish and actually answer properly to make sure that you have a good design for it. The resulting question should give you a thing that you can actually address, then give you a student project that better lends itself to producing meaningful results that then can be reproduced or actually contribute to a meaningful knowledge that future research can actually be consistent with. Or in the student's case, the conclusion that you come up with actually means something and answers a question and is likely to be more consistent with the research that has been done before, right? When they're reading those previous studies and they get a result that has nothing to do with those previous studies and seems to contradict them, well, maybe make sure that you're actually answering the research question that those previous research studies were answering, and make sure that you are consistent with this. Because again, it can be discouraging for students to have a result that is inconsistent. Either they think that they're right, in which case they're coming the wrong way with the wrong conclusion, or they are recognize that, oh, I got a weird result. This doesn't make any sense. Why doesn't it make any sense? Well, you came up with a research question that doesn't actually address the same curiosity those other studies were doing, which can be a discouraging thing to have to realize at the end of your study as opposed to at the beginning. You can set yourself up for success. All right, that is what I have to say about turning curiosity that students have into good research questions and how to help them do that by thinking procedurally about how to evaluate the question that they have and refine it into something that works better. Thank you very much.